All right, welcome everybody to week 15, day 1. I'm just going to do a little bit of live coding here. I started on the hash table assignment about half an hour before class began because I figure we need to get an auto grader for this thing. So the insert is working fine. It's pretty easy to write. Now I'm going to do search, and I just copied and pasted my insert code, so I need to refactor this a little bit. So we're going to be taking in a hash table. That's a pointer. An integer that's the key we're searching for, the size of the array, and bitmask, which I will explain later. So we don't need you yet. Let's see. Okay. So if we're going to be loading from, we want to load the value there. Let's see. We don't need to load from it, do we? Do we need to load from it? We don't. We don't have randos at all, do we? Okay, because we are just being passed the key. So we need to start off by figuring out what bucket key modulus size is, right? Seems like a good place to start. And then after that, we need to compute the offset, which is what I think a lot of you guys were not doing right. Remember, there's base plus offset. The base is going to be the hash table. The offset, well, we'll do that in a second. Okay, so let's see if we can figure this out. This is going up on YouTube, so we'll see how this works out. Figure out what bucket key modulus size is. So if we pass in 10 and the size is 8, then the modulus should be 2, right? Okay, so the key is R5, so I've saved that in R5. Technically I could be using R1 right now, but you know, whatever. And then how do we do modulus? Okay, so let's do and. Let's save this into R8 as the bucket. R8 will be the bucket, and we're going to take R5 and it with R7, the bit mask. Okay. So bucket is equal to key modulus size. Okay. Any questions about that? Yeah. What do you mean no? What do you mean no questions? You should have a question about this. You should have all sorts of questions with no, I'm fine. I understand what's going on here. You shouldn't understand what's going on here. So R5 is the key we're passing in. We're doing search. So let's say we're searching for 10 and a hash table size 8. Okay, we should get 2 as a result. So R5 is 10, it's the number we're searching for. R6 is the size of the hash table, in this case 8. Bitmask is actually 8 minus 1, it's 7. Okay, and so I'm doing a bitwise AND between 10 and 7. Bitwise AND between 10 and 7 is going to be 2. You guys need to see that? 10 is 1010. 7 is 0111. So 1010 ANDed with 0111 is what? 2. So so this is doing modulus in ARM32 assembly, which I thought you said was impossible. All these people saying no. 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 I understand. You shouldn't understand. You should not understand. My lord. So we can always replace AND with modulus? No, not at all. This only works if there's a power of 2. If you're doing a hash table of size power of 2, this trick works fine. And so bitmask, I don't actually technically need to pass it in. I could just take size and subtract 1 from it. That would give me the exact same thing. Let's take a look at this. let's see, I need to switch my streaming screen. Only works for powers of 2. So today is 420. Nice. Okay. So if I let's say that the user typed in size equals 18. What I do is I do a log base 2, and that gives me what was it? 2, 4, 8, 16, 4. And so that gives me 4. And then I take it 2 to the 4th power. 2, 4, 8, 16. That gives me 16. And so I set size equal to 16. So whatever number they pass in as the size of the array, I actually round down to the nearest power of 2 by doing log 2 and x2. That will get the nearest power of 2 below the size. So if they type in 1,000,000, I don't know, it's whatever power of 2 is smaller than 1,000,000. 512,000, I think, right? So so that guarantees that my thing is a power of 2. And so the bit field, which again, I didn't really need to pass that in as a parameter, but I don't know why I did. So bit field will be set to 15, right? So it's going to be 8 plus 4 plus 2 plus 1, right, in binary. And so if we try hashing the number 35, right, 35 modulus 8 is equal to 3. Yeah. So if we try hashing 35, 35 in binary is 16 plus no, we'd be modulusing by 16. Let's pick 8 because I already have it up on the board. So if they put in a size of, let's say, 10, the bit, or if they put in a size of 10, that'll pick a size of 8, and the bit field will be this. It'll be 7, right? It's that. And so if we're like, all right, let's do a modulus of 35. 35 is 16. 35 minus 16 is 9. 8, 0, 0, 1. And no, it's 24. All right, why is my brain not working here? 35 is 1, 3 zeros, and a 1, 1. Okay. One, 3 zeros, and a 1, 1. Come on, give it to me. Give it to me. Come on. Whatever, I'll scratch it out. Okay. So that's 35, right? 32 plus 3. Thank you. The 32's digit, that's the 2's digit, this is 1's digit. Thank you very much. Okay. And then 7 is 0, 0, 0, 1, 1, 1. This is 7. This is 35. This is 7. And so if you bitwise AND them together, you will get 0, 0, 0, 0, 1, 1, which is 3, which is modulus. So 35 modulus 8 can be computed by doing a bitwise AND with 7. What do you guys think? You turned off -03 to get a faster time. That is correct, Malia. Yeah. And so I told you guys when I gave you the assignment, you can use a smaller hash table size. You just can't use a bigger one. Because that's obviously a very easy way of getting better performance out of your code, is to just make the hash table bigger. Right? You can't. Yeah, there's a upper bound, but I didn't say you couldn't shrink it. And I mean, technically, you don't even need to shrink it, right? You can just not use the whole hash table. It's fine. This is some fast and for square root BS. Thank you. Thank you. All right, so all right. Awesome runtime of 6 seconds. My goodness. Well, I shouldn't say anything because I haven't actually benchmarked this yet. I was I was going to work on this last night, and a friend of mine wanted to play video games, and so I was like, oh, I'll just log in at 11, and then my mom calls, and we had talked about business. So I actually only started this at about half an hour before class started. Okay. So this is modulus. Now you should understand it. Anyone have any questions? No. Okay. It makes sense to me. You're doing an and. Okay, so that is the bucket. Now we need to compute the offset. And the offset of bucket 5 would be 20 bytes, right? So for that, we just do a logical shift left by 2. So the offset, well, I guess we can just leave that there, right? Okay. The offset is always going to be the bucket times 4. So R8 is the bucket we're on, and then R12, I guess, is the offset. Okay. So we don't need a store on this one, right? Well, let's go through this. Okay, so inner loop 2. Okay, so offset is equal to bucket times 4. So if we're on bucket 5, the offset is 20. It's 20 bytes to the right of the base of the hash table we pass in. Hash table is U. Okay. So we're going to load from the base plus the offset, right? Are you guys familiar with that terminology now? Base plus offset. Like, base is the start of the array. The offset is how far into the array you are. You got to internalize that. Okay. So base plus offset gets loaded into R0. Do I want to load it into R0? Do I want to load it into R0? I guess. I'm not printing anything yet. So I guess we can do that. Okay, so that's going to load the value of the hash table at that bucket. And we are going to compare that value against the key that's passed in. So I need to make that R5. If it is the key, return true. So if it is the key, compare R0 with R5, return true. And so technically I could probably just return right now, because R0 actually has a, yeah, I'll be proper. It's expecting a Boolean, so whatever. Okay, so move if equal R0 1. I think I could probably delete that line, but put true in the return value, because remember, none of the buckets are going to be 0, right? So should be fine without that line, but I'll just set it to 1 just in case. You know, C++ demands 1. It shouldn't. Okay, so put true in the return value, and then we will branch if equal to done 2, because I have a done 1 up there. So that is the code that will search, and if it finds it, it returns true. Otherwise, compare R0 with 0. If the bucket is empty, return false. And again, R0 has like the right, yeah, R0 is still good. I have not done any branch of links. That's the thing you always got to watch out for. Like, you know, if I had put in like a print int or something here to print out the value of R0, then R0 would be corrupted, and I'd, you know what I mean? And so that's why I was kind of nervous about loading into R0, just because, yeah. But it's an optimization, because I'm technically, what I'm going to do after I write this is I'm going to delete that and see if it still works, right? Because it shouldn't be necessary, but I'm just doing it as a safety measure to begin with. Because basically, whatever value I load into R0, R0 is also the return value, so I can just quit at this point. So compare R0 0, and then again, F11, what is that? Branch if equals to done 2. So, I don't even have to move anything to R0 there, because I just verified it's 0. So if we loaded from the hash table 0, just call return, and we're good. Okay. And then otherwise we have to go to the next bucket. So go to the next bucket. So add 1 to the bucket. Our bucket is R8. R8. And we AND it with the bit mask, which is R7. Okay. And then we branch always to the top of the loop. We then multiply the bucket by 4, load again. That should be good. Right? See how fast that modulus is. Okay. A modulus is oftentimes actually the choke point for a hash table's performance, because if you're doing 80 cycles on every bucket, like that's a lot of room for improvement, you know. And so I am making the hash table smaller. And so that's going to have a performance penalty. However, the load of the bucket originally was never supposed to go over 50. And so it's possible we're going to get into like a 90% load situation. So we'll see. We'll see how it works out. This should work. This should work. Is that it? Okay. Oops. Find a reference to loop 2. Yeah. Stop. Just looking it over just to make sure. And if it doesn't work, then we have to go into debugging mode. 1 and 10. Your code is correct. Boom! First time. What up? What up, playa? That's how we do it. All right. Get rid of all the debugging information. You know what? Let's try it on a few more sizes first. Before I get too excited. Code is correct. 10,000. 10,000. Code is correct. All right. Cool. Now we'll pull up the debugging information. I've tried it on 4 cases. Clearly it is correct. All right. So I was just printing out the hash table just to look at it. Just make sure I don't delete anything important. Hopefully I didn't break main. I deleted that pretty quickly. Should be fine, right? Yeah, good. All right. So let's try it on size 10,000. It's about twice as fast as the C++ code. Let's try it on size 100,000. I could cheat and do powers of 2, you know. Oops, 100,000. Maybe I'll do it. But I'm doing powers of 10. That way I'm not really, you know, squeezing an advantage for me. 1 million. Ooh, it's slower this time. All right, all right. 100,000. It's faster. Okay. Yeah. So let's see if I can squeeze some advantage for myself. Let's see. 2. Let's see, 2 to the 22nd power. Okay. Control C. Okay. Yeah, so yeah, it's faster. Let's see. U.S. View. Is it faster? I don't know. Maybe a little bit. Okay. It's going to XOR a bit number filled with 1s above that. Yeah, that should work. I guess. Maybe. XOR flips the bits, and so if you had a 0 before, XORing it with 1 would make it 1, so you can't use that for hashing. And is the right way of doing it. Cool. Now it's faster. Turn off -03. All right. If you insist. See if there's any other options I need. Guess not. Technically, I don't think that does anything. Okay. Oops, what's going on here? Make our make file a little more proper. Oh. S, oops, 10S, okay. STD. Typically, you just make a variable called CC flags and you just put them all in there, but I'm just showing you guys how to make variables inside of makefiles. And so, yeah, do that. And just that everything looks the same. We could do this. Make clean, make. See if it's still in the thing. So, okay. Now if we turn off the optimizer, -O0, make clean, make my code is buggy. That's odd. The optimizer shouldn't affect correctness at all. Very odd. Okay. Anyway, you can see that the C++ code is now running 3 times slower to generate the random numbers even. The hash table code is now over twice as slow. And my code is slower as well because the C++ code that's calling it is not going to be optimized either. And so, yeah. That's not cool. Back to being correct again. Huh, I'll have to investigate that. Is there a bug in the C++ code that changes behavior if the optimizer's off? That's a little scary. Okay. Yeah, anyhow, you can see that that code that I made is it's faster. It's good enough for, you know, just kind of spitting out a solution. Okay, so yeah, let's go ahead and make an input file and put file 0 and file 1, 100, 2, 300, 3, 4. Oops. 5 and some random size. FileMaker. Yeah, go team. All right. Now we'll go ahead and grade this, and we'll get the sudo collect homework csci 45 hash table ASM hash. Damn it. ASM hash. There we go. All right, it's grading it now. All right. So yeah, the homework's not too bad, I don't think. Optimize your change output. Report. I'm gonna alarm clock lol. Yeah, I'm gonna need. There we go. Segfault. I actually have updated the auto grading script. Let's see here. Cancel that. So move my collect homework script up into my code directory, and then we will SCP secure containment protocol from wkernel at csci.com /. What is that directory? There /correct. No. Wrong directory. Wrong directory. There. To here. Ooh, what is your password? Got it. All right. Then collect homework. Okay. Chmod user may execute. User can read, write, and execute. Collect homework. Okay. Sudo collect homework csci 45. Let's see if this works. There we go. So what I did was I switched out the timeout code. I had been using a program called doAlarm. doAlarm allows you to run a program and set an alarm on it, and after whatever seconds you pick, like 5, it sends an alarm signal to the program, which kills it. The trouble is the alarm is either based on wall clock time or CPU time. And if it's set on wall clock time, then your code will get cut off after 3 seconds on the, do you guys know what wall clock time means? Like if you're looking at a clock on a wall, when 3 seconds have gone by, you're like, all right, kill it. Trouble is if other people are running programs on the server, then people's grades will be affected by it, because if you've heavily loaded the server, then somebody who's like marginal and like close to that 3 second time limit is going to go over, and they're not going to get a point for the test. And so what I was doing instead was running it with CPU usage time, which isn't affected by wall clock at all. It's like when your program runs, it's got a accountant sitting there writing down all the usage you're using, and then when it swaps out, it doesn't cost you anything. Then you swap back in, and then it starts recording how much CPU time you've eaten. And you can actually charge people based on how much CPU time they use. That's like how AWS works, right? But that functionality has actually been in Unix for, I don't know, since the beginning of time, I think. Like, these things were originally time-sharing systems, and so you'd have an IBM mainframe, and you would oftentimes, like, different departments at a college campus would purchase CPU time on the mainframe. And so different departments would essentially pool together to pay for a mainframe. But they would pay for it based on how much they used. And so there have been accounting systems like that just track how much you actually use, not how long it took to finish, because there's a lot of people running the server, it's not your fault. Just how much you actually use, how many cycles, it counts how many cycles you use. And then it charges it to you. The trouble is with that is that if your program hangs, like if your program goes into a state where it's like waiting on input and it swaps out, it won't wake up until the user types in something. And so the thing won't actually kill your program, because it only kills your program after it's consumed 3 seconds of CPU time. And if it's just waiting on input, the operating system swaps it out and says, yeah, don't do anything until somebody types something. So I switched out do alarm with GNU timeout, which I think is just a better product anyway. So you get to run a command with a time limit, and it's got some nice features, like the exit code of do alarm is different based on what kind of timeout we got. So if it timed out using CPU time, it was like, 142 or 129, depending on whether it was wall clock time or CPU time. And with GNU timeout, you can actually have it just return the error code of the program if you want. I don't. I actually want GNU timeout to report if there was a timeout. Then I can kill your program. So it'll print, when I'm grading your code, it will print time limit exceeded, right? So what I do is I run your program, and then I check the return value of your program. Do you guys know how to check the return value of a program? CPU time isn't always better. Yeah, like if you're doing benchmarking, like if we're doing a benchmarking competition and we want to know who's fastest, it shouldn't it shouldn't matter if you're running your program when there's other people running on the server, right? So CPU time is actually a pretty legitimate benchmark. The only downside to it is if it's heavily loaded and you swap in and out, you're going to get more cold start cache misses, because when your program swaps out, probably everything you had in cache is gone by the time you swap back in. So if you're able to run for longer without swapping out, there's still going to be an advantage on running on an unloaded system, but it's not nearly as bad as if it was wall clock. Like imagine there's 10 people trying to run on one CPU. So if there's 10 programs trying to run on one CPU, you might say, okay, for a tenth of a second, run the first program. Then you swap it out, swap in the second program, run that for a tenth of a second. Swap it out, take the third program, run it for a tenth of a second. So for every second of wall clock time, in other words, you look at the clock on the wall and a second ticks by, each one of those 10 programs has gone a tenth of a second. And so it would take 10 times as long for your program to run. Probably a little bit worse, actually, because you got to swap in and out and stuff like that. But and so if we're having a competition, and I'm like, all right, person who has the fastest running time gets an A, then the people who run it at 3 o'clock in the morning when nobody is on the server, 7 o'clock in the morning when nobody is on the server, they would have an advantage, right? Because they wouldn't be competing against other people. And so the doing a CPU time computation is more accurate, because it actually is saying how long did your program actually take to run. If it's unloaded, they're usually pretty close. But on a loaded system, there could be quite a significant difference. So, yeah. And then for my auto grader, it makes a difference, because I kind of want to kill your program on both, right? So like, if you eat up 3 seconds of CPU time, kill it. Or if, I don't know, 10 seconds of wall clock time go by, because that means your program's hung, kill it. And I have to do that on every test case. So if there's 10 test cases and I kill a program after 10 seconds, that's a long ass time. That's 100 seconds for one student to be graded if they have a program that's hanging, right? If the program returns immediately, the autograder is very fast, but I'm fairly generous with my time, you know, literally. And so it can take a while to grade the code just because I give students enough time to make sure their code is working. Ooh, wow, look at that. Oh, right. Yeah, I don't have the cheat checker installed on here, do I? Yeah, I need to cut that out. Okay. For now, let's turn off the cheat checker. All right, so have I shown you guys my collection script before? I'm kind of proud of it. Would you like to see what a real Unix shell script looks like? 3 a.m. very busy. Yeah, Nico's asking when's the best time to, because we're getting a new server, right, for the department. And he was asking when's a good time to take the server down so he could do a backup. And I'm kind of like, I don't know, like my current server backs up automatically without needing to go down. I don't know, it seems a little amateurish to me, but he was like, what about every night at midnight? It goes, I'm like, no, don't take it down at midnight. What about 3 a.m.? All right, well, when are computer science people asleep? I'm like 8 o'clock in the morning, 7 o'clock in the morning. Midnight is prime time. Yeah, 6 to 7 in the morning. That's, you know, yeah. So, yeah, you can see on the main server right now, we got tons of students on there right now. And on the Raspberry Pi, got a few people on the Raspberry Pi right now. Okay, yes, let me show you the script. So this is TC shell scripting. People have asked me before why I use TC shell instead of bash to do my scripting. And there is no good answer to that. TC shell is 100% inferior to bash. Bash is just hands down a better scripting language to learn. TC shell is, there's some things you just can't do in it. like you just can't redirect, like you can redirect output, standard output, you can redirect standard output and standard error together, but you can't redirect them to different files. Bash can do that very easily. Like just basic things like that, like TC shell can't do. You can kind of cheat it by having a subshell and you redirect the output, standard output of the subshell, and then you run that inside another shell and you redirect both of those into another file, and then the subshell redirects its output into one, and then the outer one is doing both, but technically since the standard output is going to one, it goes into the other. So there's ways of kind of hacking around it, but basically, I would say don't learn it. I would say don't learn it. Learn bash. Bash has a lot of examples and documentation. TC shell doesn't. If there's something weird in TC shell and you're trying to figure out like, how do I redirect, you know, the file descriptors to different files? Finding documentation on it's nearly impossible because the documentation was written in the 70s and nobody's bothered to preserve it. Examples are very hard to come by for doing things you want. How do I do a loop? You know, like, good luck finding that. Yeah. TC shell. I don't know. Let's see what we came up with. How do we do a for loop? TC shell for loop. All right, that's coming up. All right. C shell. Yeah, C shell's close enough. Really. Bill Joy. You guys remember who Bill Joy was? Yes. Founded Sun Microsystems. Made Vim. Or VI. Yeah. Did a lot of things. So he made this too. Cool dude. Yeah. So, okay. There you go. There's some good examples. It's C shell, not TC shell, but it's close enough. TC shell is like the C shell. Anyhow, so the reason why I use TC shell is because the syntax looks like C++, and so I don't have to code switch. If something, then, and if It's not exactly C++, but it's close enough. In Bash, you do the same thing with square brackets, and it doesn't, like my brain has to shift gears going back and forth between C++ and Bash. With TC Shell, it doesn't. And so I just admit it's not a good choice, but I do it anyway because I can write code faster in TC Shell than in Bash. Okay, so this is how you set a variable. This sets a variable named UID to be 1000, sets group ID to be 1008. Username is set to be wkearney. Yeah. So if you want to do an if statement in scripting, so if a program called doAlarm works, then we're going to set these timeout codes. Otherwise, we'll set some other timeout codes. If that means if exists, I probably. This is saying if the program exists. I think we probably shouldn't even be doing that anymore. Let me just run this real fast. Echo doAlarm. Go. All right. Okay, it is being set to timeout. Okay, good. So echo, by the way, is how you print things in shell scripting. And let me just, for the hell of it, print out the timeout code. Just to make sure it's the right, for the right version we're using here. 124. Okay, good. Right. So then backtick. I've shown you guys backtick before, right? Discord said no to Microsoft. Good. So have you guys seen Backtick before? It's the cheat console character, if you're a PC gamer. So you might have seen me like earlier in the class. I did like vim which compile. So which is a Unix program that locates things for you, because I can never remember where I put things. And so I just run which. And so this is a shell script. And if I want to edit the shell script, then when I say vim backtick which compile, what happens is that actually runs a Unix shell. It actually runs the program which compile, and it replaces whatever's in the backticks there with the output of the program. So it's running a program which compile, and then that bit that I have there highlighted gets erased out of the command prompt, and the words /bin/compile get put there, and then it opens the file. So it is really, really cool. It's actually running a program to come up with what the first command line argument is to vim. And there's a lot of neat things you can do like that. Then homework. And so here, this is running a program called ID, which tells you who you are. Here's my user ID, my group ID, what groups I'm in. I'm in these groups, blah, blah, blah. If I do ID-U, that's my user ID. So I'm user ID 1001. If I run this with sudo ID-U, I am user ID 0, which is root. Okay. So what it's doing is saying, am I running this as root or not? If my user ID is 1001, If I'm running it as root, then yes. Okay. So this code here is saying if, and then it actually runs a Unix shell. And it runs a shell script, essentially, or a Unix command. And the output of ID 0 gets put within the if statement. So can you imagine that in C++, where you just have inside of an if statement, just run another program, and the output of it, the string of that, literally gets pasted into the if statement. It's, you know. So, no, and you can do this in Bash too. It's a Unix thing. So this is literally dumping the output of a program inside of the if statement, And so it'll say if 0, which by the way works fine in TC shell. This wouldn't, I don't know if you could even do that in Bash. You'd have to redo it a little bit. Square brackets and say if it is equal to 0, basically. So basically if false, right? So if false, it does not run this. So if my user ID is 0, it skips over it. If my user ID is positive, then that's true in C++, right? So then it says this program must be run as root. That's command line parameter 0, command line parameter 1, command line parameter 2, command line parameter 3. So if I try running this program, collect homework, IOB, then it will echo back those first 3 command line parameters. So if I were to say collect the homework from CSI 45 asim hash, then it will say error, the script must be run as root, for example, sudo ... And so I could just copy paste that and run it. By the way, I wrote this whole thing like this. I error check myself, right? I don't trust myself, trust nobody, right? Because I'll forget to put a sudo on it sometimes. And so I'm very helpful to myself. I'm very kind to myself. I double check because this code won't work if it's not run as root, because it involves going into other people's code, grabbing their code, compiling it, running it as them. So if you guys ever tried like wiping out the entire file system, it won't work. Even though this thing is running as sudo, when I compile and run your code, it's done as you. So if you tried wiping out all the files in the disk, you just wipe out your own files and not affect anybody else's. But I double check everything. I vet every input, even my own stuff that only I write only for myself. And then I quit. Exit 1 quits out of a shell script. This is the number of variables, by the way, in shell scripting start with a $sign. So variables start with a $sign. So you can actually embed variables inside of strings. Do you see that? That's cool. Do you see what's happening there? So I'm creating a variable called doAlarm, and it is being set to /user/bin/doAlarm, and then this string automatically substitutes out inside of it whatever variable default timeout is, which is 3. So in shell scripting, if you have a string, inside of the string, if you have anything that starts with a $sign, it will look for a variable with that name and substitute it immediately into the string. Do you know how cool that is? Like backtick and like the $sign substitution allow you to do things really neat. In C++, you'd have to like probably use a string stream and echo user bin doAlarm into a string stream, then echo the variable contents of default timeout into a string stream, and then convert that into a string. And in Unix, just anywhere a $sign appears, it'll just substitute inside of the string. Has a student ever tried to do goofy stuff like the wipe files? No, never. So, yeah, just letting you know. You will only hurt yourself. And so this is variables don't have to be inside of strings; they work everywhere. So this is how many command line parameters you provide. And so if you say sudo collect homework. And I don't provide enough command line parameters, then it will say usage, and so if I don't provide enough command line parameters, then I remind myself what command line parameters there are. The second command line parameter is the class name, 01. And so I take the class name and I filter it. Basically, I'm stripping semicolons out because I don't want to have any special characters at all from the user input. So I strip out semicolons. I then strip out anything that is not a digit or a lowercase or an underscore. So no special characters whatsoever do I allow into my shell scripts. The only thing I allow are digits, underscores, and lowercase letters. So if the string was changed by this filtering, then I print out you screwed up, right? So if I tried putting in like a exclamation mark here or something like that, then it will yell at you, right? Because a lot of these things do stuff. There's a lot of magic in Unix. And so I absolutely do not allow any magic. Because that's how you get like SQL injection attacks and things like that. So if you guys ever do anything web enabled, you should always strip everything anybody on the internet sends to you. Don't assume they're going to give you something, like if you're reading into a buffer of size 500, don't assume they're going to type less than 500 letters for their username. They will try typing in 501 and see if they can overflow your buffer. They will try typing in semicolons and things like that. And if you take their username and you pass it directly into SQL, and you do a SQL query based on their input, they can close off the SQL query with, you think of it as like a semicolon. In that one, start a new one, drop all tables, boom. And so their username, is, close query, drop all tables, boom. And then your database explodes itself. That's a nicer thing. There's much meaner things that people can do than that. XKCD has a Bobby tables, exploits of a mom. How long did it take you to code the entire server? About a day. The shell scripts took me about a day to put together. So when I knew that I was going to become a professor, I just sat down. First thing I did actually was I mailed UC San Diego, because UC San Diego had a turn-in script. Like I said, you had to tar everything up into a file. You call turn-in, and you turn in your thing, and it timestamps it and puts it into the TA's directory for the TA to grade. And so I asked them, hey, could I get a copy of your turn-in script? And they didn't write back. So I'm like, fine, I'll just do it myself. And then my version's better because it auto-grades. And so it doesn't require students remembering to turn things in on time. At the deadline, the auto-grader runs. It collects all of their files, compiles them, runs the test cases, counts how many test cases they got right. That's their grade. It emails them a copy of all the things they got right, they got wrong, why they got it wrong, puts the scores into a text file database kind of thing, and prints all the scores on the screen so I can see how students are doing on something. Yeah. Okay, so yeah, it took a day. It took about a day to code all of them. And then over time, like if I discover I needed something like regrading or something like that, like I added that. So it's been built up over time, but essentially about a day to do it. Hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? In a way. Did you really name your son Robert, close tick, close parentheses, semicolon, drop table students, semicolon, hyphen, hyphen? Oh yes, little Bobby Tables we call him. Well, we've lost this year's student records. I hope you're happy, and I hope you've learned to sanitize your database inputs. Right? So anytime you get anything from anyone, including yourself, right? Because I'm the only person that can run this. Right, and I still don't trust myself to not accidentally put in a semicolon and explode everything, right? So I strip everything that's not alphanumeric or an underscore or a hyphen for the name of the homework. Yeah. So it happens. Backtick, yeah, exactly. If you put a backtick into these things, then when it runs them, it'll run a subshell. Oh, goodness. No, thank you. So I sanity check everything. If I pass a no grade as a parameter, then I set a variable called no grade to be true. Otherwise, no grade is set to be false. So I can just collect your homework and not grade it. So I have a copy of it. For the RPGs, I do that. If does not exist the class name, then it says file class name does not exist, quits. Okay, so let's go through the thing. Okay, so I have to have a version myself ready. And so if it's not found, then it'll print an error to me like, hey, you need to do the homework assignment yourself, like I just did right there. Make sure that it's executable. Sometimes permissions get screwed up. Like if I back up the server and reload it, like the permissions get turned off. And so sometimes I have to turn the bits back on or just do a make clean make and rebuild it. And so it checks for all those things. It checks for all those things. Okay, here's a cool thing. You know how I said Bash could do things that TC Shell can't? Guess what TC Shell can call Bash? You guys see the backticks there? So TC Shell is saying run Bash. here's something I can do. So run bash and have bash do it for me. So bash with a -c means run this command. And so bash will run this command in double quotes here. And it will run the reference implementation, redirecting the standard error to dev null. So if you guys print things to standard error, I don't see it. It gets... oh, wait, no. That's different. If there's an error message, it redirects any of the error messages to dev null. And this is something that's bash syntax for redirect file descriptor 2, file descriptor 0, standard input, file descriptor 1, standard out, file descriptor 2, standard error. So take standard error and redirect just the standard error to dev null. TC shell can't do that. And so I'm just like, bro, help me out here. And so I have bash do things that only bash can do. That way I can keep my smooth brain. I need to see it looking like C++ thing here, looking like C++, and then I can use bash when I need something that's bash specific. So yeah, like you calling modulus in C++, right? Exactly. Right. Okay, so the data files, and so this is going to grab all of the input files. I don't really use that very much. I check to see if a directory structure exists. If a directory does not exist, I create it. If a class does not exist, I create it. If a homework directory does not exist, I create it. So I build a directory structure. I have one folder that has all of my classes. Each class has all the assignments. Each assignment has the grades and all of your code in it. So there's this big directory structure that I have every homework done by every student ever in it. I then create a grade file. And then if I am regrading, then I back up the old grade file just in case somebody broke something. I can go back and be like, oh yeah, you got it right the first time, but you broke it before the regrade. And so what happens here is that move will do a numbered backup. So if you do this, if you run this regrade multiple times, it'll go grade file old 2, grade file old 3, grade file old 5. So every time I regrade it, I don't lose any grades ever. It does automatic numbered backups for me. Just a cool little thing there. I chown, that's change ownership, to me. I own the grade file. This creates it, so I cat from dev null into grade file. Another way I could have done this was touch grade file would create it if it didn't exist already, but this will erase an existing grade file if it was there. So this dev null is the trash can. So if you try catting from the trash can into a grade file, it can't read from it, so it just creates an empty file and quits. I set the permissions to user can read and write, group can read, students cannot see anything of the grades. Does your script still send the sdiff? I don't see it in Alpine. Maybe. I haven't checked in a while. Now here's the main loop. For every student in the class, and this is a hell of a for loop. So this is saying for each student, and then for every student that is in this file, it's going to run the autograder on that student. So it backtick, look at that, backtick. So this is running a UNIX command, and the UNIX command is going to result in a big long string, and that big long string is going to be stuffed inside of the parentheses, and one at a time, student's going to be set to Alan, student's going to be set to Afafong, student's going to, and so I'm catting every student in the class, piping through cut before semicolon to get rid of any semicolons in the student file, which there shouldn't be, but I don't trust myself, so I get rid of them anyway. And then I cut before spaces, so that if there's multiple students on one line, which there shouldn't be, I get rid of them. And then I tr is the translate command, so cut everything that is not an alphanum, an alnum, an alphanumeric, or an underscore. So student usernames can only be letters, numbers, and underscores. And so that I could have just done it with just cat class name backtick, but I don't trust myself, right? And so it just filters out any potentially game-ending mistakes. You know what I mean? I then run the ID command. The ID command will give you the ID of a user on the system, and if they don't exist, then it'll return an error. Actually, do you guys remember that? From like the first time we did assembly, that's the error code that's returned. So If an error is returned by the ID command, that means they don't exist. And then I print out an error. Like I think I've deleted one of my students out of CSI 41. He hasn't done any homework, so I deleted him off the server. Apparently he's still in the class. So that's a bit embarrassing. But he hasn't complained yet, so I don't know. When you do large projects like these, how do you approach them? Do you just dive right in, or do you take time thinking about how you want it all laid out and what functions you need? Yeah. So that's a really good question. And so this shell script here is 506 lines. And so it's big. It's not that big, but it's big, right? And so I start off by building each of the individual pieces, right? Like, can I, like I would just start off by doing this for loop here and say echo student, something like that, right? And I would just echo, and I would just make sure I'm getting, okay, every name in the class for each loop. It's going to, and then I'm like, all right, now see if they exist, right? Now make sure their user ID is over 1,000, so we don't allow root accounts to be graded. And I build up, like just that loop, I'll build up, and then I will add sanity testing to it, make sure the student exists, and I grow just that loop. And then I'm like, all right, now that I'm successfully getting a list of every student in the class, now go into their directory, copy all the files out. And so I don't actually copy all the files, I copy specific files. Out. And then I run it, right? So you just work on a little bit at a time, and that's just like for grabbing the student stuff. The other stuff, like all the like when I'm just verifying the command line parameters, add a little bit at a time, test it, add a little bit at a time, test it, add a little bit at a time, test it, and you just grow it like that. But yeah, as far as like the overall structure of it, I had to sit there and think about it for like a good 10 or 15 minutes. Like, how do I want this organized, right? Like I could have it so that I could have one directory for like #hash, and then having subfolders in that for each year, right? So for the #hash assignment, I could have students' assignments from 2015, 2016, 2017, 2018, right? And so I could CD into it, and I could look at the student submissions from different years, which would actually make it easier for me to do cheat checking, right? Because then all of the assignments are together, and I can do a n² diff, for every student across time, diff their submissions and see if they're the same, or if they're close. And if they're close, and also doing things like stripping out variable names, stripping out comments, things like that, and then see how close they are. And then I would manually go in and look to see if they're cheating. So I thought about that, right? But then I was like, but what if I wanted just to see everything one class did? Then it's not organized in a way that I can get at it. Like I can't see what assignments the 2017 class did, right? And so, but what if I want it organized by students? What if I want to get every submission a student did? Because it's fairly common for students to be like, hey, Kearney, you remember me? I took your class 2 years ago. Could you send me my homework? And so maybe I want it organized so each student gets their own folder. And then if you take me for multiple semesters, I will have one folder with like your 40 stuff and your 41 stuff and your 26 stuff. And so there's different ways you can organize all this stuff, and I really thought about it. And I realized, like, if I needed to get all the students' stuff, I could just write a shell script to go into all the different directories and find their stuff and put it together, which is actually what I did. So in the turn-in directory, which is organized by class, like you guys see this? So every time there's a new semester, there's a new class. So fall 18, fall 19, spring 17, CSI 26. So these are all the different classes I've taught. Man, that's a lot. Huh? That's not counting the IS 50 stuff either, huh? I guess there's a couple of them, but most of them don't get accounts on the server. So I've got a shell script called backup.sh, chmod user may execute TCSH. And so this is a shell script that will grab, like for example, if I want to get all of Torres's files, then I'll type backup Torres, underscore whatever their student ID is. And so this is a small shell script, right? So find from the current directory. Find is a Unix utility that it's a search. It's like a Windows find, right? When you Windows key F and you search for a file, it goes through the directory structure. So dot means the current directory. So find everything in the current directory, including all subdirectories. Everything that matches $1 is the command line parameter you pass in that matches that name. And it writes the results of that into a file called mudkip. Technically, I don't need to do this. I could have embedded this into a backtick, but I did this so I could look at it and just make sure that it was working right. Then remember how we talked about tar last time or 2 times ago? Tar tape archive will zip up a directory for you. So create Torres 066 whatever .tar, and then it just provides tar a list of all the files that Torres has, and then that will grab because I create a subfolder for every student. So yeah, it's semester, assignment, student, folder, and so what this is going to do, it's going to find every folder that has that student's name on it, and it dumps them all into a tape archive, and then gzip it. I could have just done that with a CFZ, like I showed you guys last time. Again, I'm kind of taking it step by step because I like to verify after every step that it's working. I could make this whole thing a one-liner. All 4 of these could be done on one line of shell scripting, but I got nobody to impress. And if something goes wrong, then when it's on separate lines, I can see what's going on. But technically, all 4 of these could be combined into just one line of code. If an error occurred, then we quit. Otherwise, sorry, that's the number of command line parameters. So if I just typed backup Torres, then it creates a tar gzip file of all of Torres' stuff. If I also pass in an email, then the number of command line parameters is greater than 1, right? And then it will cat torres.tar.gzip into mail. And that's how you can email people. Pipe the results of this cat. Cat just reads a file and prints it to the standard output. So the standard output is going to get fed right into mail. That's the email address they pass in with a subject of csci4x backup. And so this takes their entire directory, puts it into a tar file, zips it, mails it to them, prints it, and then deletes the temp file. So there you go. So, yeah. You can request our homework from me. Yeah, sure. It's all there. I've got copies of every homework you've ever done. So, yeah. Does your script still send out the STIF? It's possible I didn't set up because I moved servers. So I might not have mail set up on the Raspberry Pi. Okay, so coming back to the compile shell script, this will run as you make clean, checks to see if the build failed. If the build failed, then it says failed to compile. You get a 0. Otherwise, it is going to run as you. Here we go. So once the building step is done, then it's going to say for every input file. We can ignore that. For every input file. We copy it over, we give you permissions on it, and then here's where we run the program. So this is the heart of the auto grader right here. So this runs GNU timeout, so this will kill your program if you run too long. Sudo -u means run it using your credentials. So you don't, if I didn't have that there, your code would run as root, which would be very, very bad. Here. So runs it as you, and again, there's a do alarm on that as well. So there's a do alarm on the whole command, there's a do alarm on your command. So yeah. That stops different infinite loops. It reads in the input file, and it writes the results into a file called student results. and all of the standard error gets written to dev null. So no standard error appears on the screen when I grade. Sometimes, though, I do want to see it. Like sometimes the standard error shows like your running times and things like that. So I can actually switch which one of these lines run. Either this one, which hides your standard error, and this one, which shows it. And then I can just get your running times and just use that to score your grades that depend on running times. So you can see the only difference here is that I'm redirecting the standard error to dev null on that one. If you timed out, then it prints out program timed out, sends it to the screen, and also writes it into a file called student results. And if your results file is too big, it truncates it. It runs my program, same thing. If your program's running forever, then it checks for that too. And then here is the other heart of the autograder. So this is going to do a diff comparing what your program output with what my program output. Okay? So basically, at the end of the day, for every student, for every input file, run your program and compare the output of that program against mine. Okay. If diff returns an error code, then yours is different. If they're the same, then else. If they're the same, congratulations, you got it correct. We increase by 1 the number of points you got, and yeah. And so it's just going to count how many times. If you get it wrong, then it does the sdiff, which does a side-by-side diff between what you did, what I did, and it writes that into a diff file, which shows the difference in the two programs. And then that's going to get emailed to you eventually, although, again, mail might not be set up right. And at the end of the day, it is going to write your name, colon, your score, and it's going to save that into a text file. And it will email you, somewhere in here, it emails you the results. I might have that turned off on here right now. I might not have mail set up. Yeah. Oh no. Yeah, right now it's turned off, it looks like. I have it commented out right now. But yeah, basically what I do is I take your diff file, which shows all of your errors, and I mail it to you. Normally. Ooh, what did I change? So that is Unix shell scripting. And, not quite a nutshell, because I've been talking for an hour and 15 minutes. But so far we've gone over the hash table in assembly, and we have gone over shell scripting. So I'm going to push out your next homework assignment now. Yeah, we've been talking about call, and I've got 2 different assignments for call. One of them will teach you guys how to use GitHub and to coordinate and make libraries and send libraries to your partner and use libraries and stuff like that. And the other one is you making a compiler on your own. So which one would you guys prefer? I mean, I figure you'll do both. We got a couple weeks left. Looks like it's about evenly split. Looks like GitHub is gonna win. All right. Okay, so we'll do that. So partner up with people. How are we gonna do that? How do we do partners? So we got students that are active, and we have students who are not active. And that's, can you pick? Nah, not at all. Let's do random groups. Oh, look, I have a shell script for that. CSI 45 S6, and group size. Notice how it prints the thing. We'll do groups of 2. Okay. So Afvong is on his own. Sad. Okay, so Lave and Mueller. So you guys are both online right now. go ahead and message each other, please. Zach Hazard and Leo Lave. Gross and Singh. Gross is here. Singh is here. Okay, both of you guys mail each other. Lay and Jacobson. Lay is here. And Jacobson is here. Cool. So far, so good. Garcia and Shami. Shami's here. I don't see Garcia. Is Garcia here? Okay. So Mueller will switch with whoever's solo. You don't want Lave? No. Can we request partners? No. No. You're being assigned partners. Okay. So Shami, you're with Apavong then. Jeff and Shami, please message each other. Walker and Casey. I saw Walker a second ago, right? No? Did you just leave? I know that was walk up. Sorry. I don't see Walker. And is Casey here? Nope. All right. Well, if you guys are watching, I don't know. Trangiao. The people that aren't here, I'll do something else, I guess. Trangiao and Walk Up. Trangiao's not here. People leaving. All right, Walk Up, you're on your own for now. Muya and McVicker. Should be a good group. Muya is here. Is McVicker here? McVicker is active, though. So, you guys are in a group. Maine and Guerrero. Whatever. These are the groups. So I'm going to take this and dump it into a file or something. There you go. Then public groups. Okay. And then I moved some people around, right? Like Garcia. Shami. And then was there anybody else I moved around? You're not there? Ribera, you're with Dahlberg. So Jeremy. Cool. Green Baker, you're with Watson. Okay. So Trandabello, Hazelton Valley. All right. So these are all in /public/groups. Chmod. Everybody may read /public. Everybody may read public groups. Okay, so check on there, and I can make groups, I guess, on Canvas as well for you guys. So for this homework assignment, it's going to be called it's called Code Tennis. Okay. Vim team.a.cc. All right, so this is kind of a weird assignment because the two partners do completely different things. And you're not actually really even supposed to really talk to each other about it. So you're actually supposed to keep what you're doing kind of secret from your partner. All right. So what one person's going to do is they're going to be in C++. They're going to make an array. And they are going to... let's see here. Call function 1 and function 2. The partner is going to supply function 1 and function 2, but they're not going to supply them in a source code file. You're not actually going to share your source with each other. Instead, you're going to share a library. You're going to make a statically compiled library. And so partner B is going to make a library that contains these two functions. Partner A is going to make an array, fill it with data, and then call these functions made by the assembly person. And it's your job to figure out what the assembly person did. For example, the assembly person could, let's see, what is this? Is this string. Yes, you have a string in, you have a string out. What's this? Width and height. What is this? And then this one is an array of integers and a size and a stride. And so basically, if you have an array of size 100 filled with integers and a stride of 3, then the assembly person has to go every third element. Stride means how often you skip, right? So if you pass in 3 for stride, every third element, they have to do something to it. And so what do they do with it is up to them. It's up to them. And you don't know. And so you're going to have to go onto Canvas and you're going to have to find out what the assembly person did to your beautiful, beautiful array. So you have to create an array. You have to fill it with data. And I think this is like a 2D... Yeah, this is going to be like a 2D array of characters, and this is a 2D array of characters that are being written to. And so you pass them like maybe a crossword puzzle, kind of looking thing, and then they might modify it, like they might change all the letters to be numbers or something. It's up to them. And so you don't know what they're doing, though. You don't know what they're doing. The assembly person, you got a cookie in your mouth, girl. And so the assembly person has to do it in secret. Don't tell your partner. And then the C++ person's like, okay, on Canvas, you're right, I think this person is like changing all of the letters to numbers or something like that. And so you can do your couts or whatever. But basically, the C++ person is going to create a library that contains main. And you're going to fill it with data as well. And the assembly person isn't going to know what kind of data is being passed to them. The assembly person has to figure out what kind of data is being passed to them. And their essay is going to be, the C++ person passed me the B movie. in text form, right? In the first one, and for the second one, they gave me the Fibonacci sequence or something, right? And so the assembly person, you can call helper functions to print things out and stuff like that. But basically, what this is going to teach you is how to link together. We've been talking about static and dynamic linking. It's going to teach you about linking and how to make an array and things like that. How are these array 2D? It's just a pointer. It's just a pointer. Is that a 1D array? Is it a 2D array? Who knows? There's no such thing as a 2D array. But there is a width and height provided here, so we're going to treat it as if it was a 2D array. And so maybe the first row is all going to be A's, the second row is all going to be B's. However you want. Come up with your own unique pattern. And don't tell them. Don't tell them. Like, and don't, maybe you can make a random array, but that's kind of boring. It's kind of boring to make a random array. You know what I mean? Just random letters. Do something cool. Gettysburg Address. I don't know. Let's do something cool, And so it's a 2D array. It's got a width and a height. And so a pointer is just the start of the 2D array. And then the assembly person has to go 10 to the right, down, 10 to the right, down, whatever. Whatever the width and the height is. You can use a pointer to a pointer, but you don't have to. 2D array is, you don't have to. You don't have to. I don't have the B-movie script. I do have all of Shrek's lines from Shrek 1 and Shrek 2, yeah. I saw a copy-pasted yesterday for the complete Kung Fury script. It's not very long, actually. So you put that in there, whatever. And so, but you're gonna be passing in a 2D array. And so you're gonna pass to the assembly person, there are 10 columns and 50 rows. And then you fill it with data, and then you pass it to them. And then the assembly person is gonna modify them. Maybe they're gonna change all of the zeros into O's, or all the O's into zeros. And all the E's are going to become 3's. They're going to leet speak filter it or something, right? And so when it comes back to you, print out. You're going to clock them and find out how long their thing takes. But, print it out. Add some code here to print it out and see what they did. See what they did to your beautiful array. Okay. So this is a mystery assignment. Okay. So you got partners, but seriously, don't just tell each other what you're doing. It's supposed to be fun. It's not. This isn't supposed to be a hard assignment. And so for this one, for the second one, you're going to pass in a pointer to an array. N is the size of the array. So like I'm going to give you 100 integers, and then stride means the assembly person should only be modifying every stride elements. So modify element 0, and if the stride is 10, then modify element 10, 20, 30, until the end of the array. Don't go out of bounds. So, yeah. So you're going to have to decide with your partner. Whichever name is first is going to be partner A, which is this one. And whoever is partner B, the second name, is the assembly person. Yep. So vim team D.S. And so you've got function 1 and function 2. Ooh, there's 2 quits. That's not good. Good too. Okay. So right now you just got a couple empty functions here. And so you're going to coordinate your code through GitHub. I'm in another class. What's going on? Okay. So you're going to have to coordinate your actions through GitHub. And, or technically, I guess you can use other things as well. You just, I don't know, SCP the files to each other if you want. You can make your directories. For example, check this out. Copy archive.a into temp. Temp is a world readable directory. Now, if I were to become Muya, let's say Muya is my partner, and I wanted to copy /temp/archive.a, I can't, right? Because I don't have permissions on it as Muya. And so if I were to copy the file into temp, then what I could do is chmod it, everybody may read /temp/archive.a, and then when I become Muya, I could copy the file. Easy. I would kind of prefer you guys use GitHub, because Git is sort of the de facto standard these days in computer science. And so learning how to use GitHub is like a crucial life skill that I have sort of shamefully neglected until now. Normally I go over it in 41, maybe even in 40. And with you guys, you just didn't get to it, right? Like 41 last spring had a pandemic happen in the middle of it. And so that sort of disrupted things. So, yeah, groups. I don't have groups set up on the server for your groups. oh yeah, slash public groups, right? Okay. But okay, so let's go over setting up a GitHub archive repo. Okay, so it's an easy way of doing this. Okay, so Muya, let's see Muya is my partner. So I should push out the directory first. See if there's anything else in here. Team A, Team B. Yeah, so you're gonna need to modify this, right? You're gonna need to modify the make file. Okay, so I'll just push this out to you guys. Sudo deploy homework c/45 s6 code tests. Okay, don't get it. Perfect partners, crab. No. Okay. Okay. I guess the easiest way is actually probably to okay. Yeah. I mean, honestly, the way that I usually do it is I do this. My workflow is usually that. So I go onto GitHub. You're going to have to make an account if you don't have one. And so I could go to my account here. And I could create a new repo. Let's see. Try and get this situated. So I can click on new and create a new repository. Can I make it private ones? Huh. Yeah, so you go into new, create a repository there, and then from the command line, what you do is you can clone into it. So when you create a repository, did I just close it? I don't want to create one because then I have to delete it. After you create a repository, you can create it with like a license and a README. You can edit the README if you want. I don't see why that matter. I guess you could like add a note saying this is a homework assignment. Don't pay any attention to me, so that random people on the internet don't try wasting their time on it. So you can edit it right here, and you can be like, "Yo, this is homework. Don't waste any time on me." And so, yeah, you can create it with a base license. I think most of my stuff is licensed in GPL. Where's the license found? Anyway, so the point is you can go to here. And so after you've created your repository, so that place that I showed you, you click on your account, click on repositories, click on new repository, give it a name. I would call it Code Tennis or something like that. Create it public, I guess. Code Tennis. Create a README file that just says this is homework. Please don't pay any attention to me. So I'd add that. I'd add a get ignore, and I'd set it up for C++. That way it doesn't upload your object files. Because what you should be uploading is your .a file. So you're going to create, both people are going to create a .a file, and you're going to share that with the other person. So, and then a license, I would just make that like GPL. Set main as the default branch. That's funny. Yeah, branches used to be called master, and then people decided that wasn't politically correct, so it's now main. And it broke a lot of their scripts, because a lot of the scripts they have on their own website still refer to master by default, and so like it's like they half-assed it kind of. Then you click create repository. Okay. Then after you have a repository, like I said, I'm not going to make it because it'd be annoying. After you have a repository, you go in there. You're going to have your README. At the README, you just say it's a homework assignment, and then here, when you click on the green button here for code, you can see that you're going to get a URL. Just click that to copy it, and then we come over to here and paste it with git clone. So that is how you clone a repository. You're listed as being in two groups. Is that a mistake? It says you're with Walker and Garcia. Ooh, interesting. So let me take a look at that in a second. So we do that clone, then it links everything up. I have to say I've never created a repository from the command line. I just do it on the website, and then I clone into it. Then everything's kind of linked up already. Let's see here, /public/groups. KC. Nope, you're only in Walker's group. Garcia's down here at the bottom. Okay. You're not in group 19. Did you cat it? Is that what you did? Did you do like a cat? Groups. Then it'll look like your username's after it, right? Because of the prompt. But no, you're in Walker's group. So cd into colors. So again, what I did was git clone, and then I pasted that URL in, and then you'll see that it has copied all of those files in GitHub here. And it's created a subdirectory called Git, and that has all sorts of things that hook into the website. So you can see it's got the URL set and which branch and all that other stuff set up as well. And so let's say that I wanted to update colors.h. I kind of don't want to because it's going to break it. And we can switch over to the other server, because I actually do have an update for it. And so what you're going to do is you are going to make a repo. You're going to share it with your partner. Okay? Your partner is going to clone the repository. Don't share the source code. Only share the archive. So you're going to make an archive. You're going to put it up on the repo. Your partner is going to clone it and get a copy of it. And as you are, normally that's not what you do. Normally you share the source code, right? But for this, it's a mystery assignment. So you're only going to share the .a file with your partner. Okay. And so cd into colors. Oops. Colors. Diff public. Okay, so here's how you upload. So basically, I'm in a repository, ls-a. See, there's a Git directory. So this thing is already synced up with the colors repository on github.com. And so if I have if I wanted to like update the README file, like I can add things to the README file if I wanted, but I've just updated the actual source code. And so when I'm ready to upload a new version to it, I do git add colors.h, and then I type git commit. Right, and then that is it has a list of all the things that I get added. All right, so all the files that I've changed are staged; they're ready to be uploaded to the server. And then please enter a commit message added inline to each function to allow for multiple includes. Okay, and so now that I have done a git commit, it is ready to go. It has said 1 file's changed, 21 insertions, 21 deletions. So in other words, 21 lines got modified. So git add, git commit, that stages all the changes you made into something that's ready to go up. And then you do a git push. And username and password. Passwords aren't going to work anymore, by the way. So as of like June, you can't use passwords anymore. And that's it. So it is now uploaded my changes to the server, and then if somebody like Muya wanted to, or let's go back to the other server, git commit, combines the add and the commit. Yeah, it's fine. There's a lot of shortcuts and a lot of scripts and things like that for GitHub as well. That's the basics though. So now I'm over here, I'm on a different account, so I can do a git pull. And you can see that the other person, one person pushes the changes they made up onto GitHub, and then the other person, once they've got the repository set up, they do a pull, and they pull those changes off. And so you can see that colors.h just got downloaded here, and all these changes, it didn't have the word inline before, it's got the word inline now. Okay, so copy colors.h into public, and then I'm going to rebuild a society with the new, is it using the local colors.h or the global one? Good question. we'll just copy the new one in here as well. Colors.age to here. Make clean make, and this is using the CImage library, so naturally the build time is abysmal. It adds every file that changed. Git commit -a adds every file that changed. Okay. Yeah. You don't want that though, because for this assignment, normally you do, but for this assignment, the only thing you should be git adding is the archive file. So you guys are going to make an archive file, AR space RCS. We'll go over that in a second. But you're going to make an archive file out of your .o files, and then that's the only thing you're going to be uploading into your GitHub repo, which is different from normal. Again, normally the repo has source and no object files. For this one, you're going to be pushing object files and no source, which is backwards, but it's kind of fun. So, yeah, you could add the .cc files to your git ignore if you want. Okay, so let's see if this works. Society/public/keto. That's not working. I don't know what's going on with this. Oh, there we go. All right, cool. All right, so society is working again. Copy society /public. Everybody may execute it. This weird lag at the beginning. Yeah, there you go. So that's Seattle, as you can tell. Don't have to worry about that for now. Okay, so yeah, I believe the instructions are in Canvas, but in case they're not, let me just go over it. So cd code tennis, then readme. Why is there no readme for this? For this assignment, you will be partnered with someone doing the other half of the assignment. You must not share source code. What your source code does must be a mystery to the other person. You person A, first partner, each of you will make an archive holding your half of the code, and the other person will link it against their code to make a final executable. Person A will work entirely in C++, and we'll make a couple arrays, fill them with secret and interesting data. And then build team a.cc into archive file, static library, and pass it to person B using GitHub. Person B will download person A's library using GitHub, and we'll link it against their assembly code. Their assembly code must modify the arrays in interesting and secret, don't tell them, ways. compile it, compile. They will compile their half into an archive static array as well, and upload their half on GitHub as well. Person A will download person B's archive, link against their code, and write a short essay on Canvas about what their partner did to their beautiful array. Person B will write a short essay saying what they did to person A's array, and guess what person A's array was. So that's what I'm going to grade on Canvas. I'm going to read both partners' halves and see if the other person could figure out what the other person did. Okay. Okay. So don't cheat. Don't share. Don't share what you're doing. Person B can build helper functions to okay. All right, GitHub Summary. Step 1, go to github.com, create an account if you don't have one, create a new repository called Code Tennis, add a license, GPL, do a README, with which you mention this is a homework assignment and for everyone to pay it no attention, and you should delete it after the okay. Click on the green button to get the HTTP link for your repository, which we call a repo. Go into PuTTY and type git clone cd directory just made, and work on your assignment there. Make when your code is ready, make an archive of your .o file via archive rcs team A or it could be team B. type git add team A.A to indicate it is to be uploaded to GitHub. Type git commit to stage all changes for transfer. These can be combined, whatever. Type in a description of the change you made if you want. For this assignment, don't reveal to your partner what you did. And then you will do a git push, and this will upload it to GitHub. You will need to enter your credentials. The other partner save it for your yeah. Send it to your partner. Yeah. So the other partner, step 1, git clone. CD into the directory. Copy the .a file. Actually, let's see what it. If you don't want to, copy the .a file into your homework directory. Link it against your code. Copy. Okay, there you go. So that's the steps for using GitHub. So basically, both partners are going to create repos, and they're going to just only put up into the repos their .a files. And then I should also probably check to make sure that AR is correct. AR, RCS, helper. Yeah, okay, that's correct. 2 separate repos. Yes, yes. You're each going to have your own. I guess you could share a repo. You'd have to share credentials on it. You'd have to grant access to the other person. Could be fun. Sure. I was planning on you guys just each having your own repo, and then you can push changes to your repo, and the other person will pull the changes off into theirs. And then they'll upload theirs and pull. Okay. Any questions about that? This will teach you guys how GitHub works in the most simplest, basic way possible. But that's good because, like I said, it's the industry standard now, for better or worse. Everybody uses it. People will look at your GitHub repos when they're trying to decide if they want to hire you. So it's a good idea for any of your projects and stuff like that to be up on it, so that people can check it out and see if they want to hire you. Downside, don't put homework assignments up on there. So, I'm not going to mention names, but former president of the ACM had all of his homework assignments up on GitHub as a way of showing off what he had done, and then students the next year were cloning his repositories and getting the answers to all the homeworks that I repeated, which are not always the case. Like, hash table's never been done before, but yeah. So please don't put homework assignments up there, because I do recycle old homework assignments because it's a pain in the ass to come up with new homework assignments for every class, for every assignment. So I recycle some and I come up with new ones. It's usually about 50-50, but it's annoying when I have to retire assignments that I like too. So, any questions about that? Git cloning creates a directory for the repo. It does. Yeah, so when you do git clone and then you paste that URL in, do it from like your home, like tilde, your home directory, and it'll make a subdirectory, and then it clones all the things into it. And it sets up all the configuration files and things like that the way that it should be. And then, so you're going to do that once for your project and once for your partner. And I would probably have it be a separate directory than the code tennis directory. And then just copy the .a file when you're done with it. Copy the .a file into that repo directory. Git add, git commit, git push goes up. Hey, buddy, new version's up. And then they get pulled and they get a copy of it. And so that's a way you can upload, download, synchronize. And this is just 2 people, so it's pretty basic. Muya wants to create a shared repository for both of them. It's fine. The only thing with that is you have to get the other person's username and grant them credentials on it. Don't name the repo code tennis. Yeah. If you name the repo code tennis, true. Did I call it code tennis? Yeah. Because that'll overwrite your directory. Right? I don't know if future students might steal my totally working Battle Sleep code. So, I don't know if people want my garbage code. Yeah, the thing is though, like, you know, they should go through that struggle of trying to order their thoughts. Yeah, and so you can't get clone into code tennis if it exists already. So, just call it anything else. And then senior directory, working assignment, yeah. Or work on it in code tennis, and then copy over the .a files later. Yep. Okay. So do you guys understand the point? You're each going to be building a library. It's a very simple library. It's just a couple functions in it. But you're going to be making a library, sharing it, linking against each other, and this is going to teach you guys about linking and stuff like that. Muya had fun with C++ linking the other day. Like I said, for simple projects, you might be under the impression that linking is a very simple thing, and the linker is a simple tool, but the linker problems are some of the most annoying things to deal with, and so this will just kind of teach you the basics of the art. Hopefully without any of the annoying bugs. Just teaching the basics of making a library and sharing it and linking against it and stuff like that. Okay. That's it for today, guys. It'll be due in a week. It's a easy, fun homework assignment. If your partner vanishes, just mail me and I'll move the groups around or something. Okay. I do know there are some students that just go AFK and never talk to anybody. And you can't do this assignment without an active partner. So try to get a hold of them. If you haven't got a hold of them by Thursday, I will redo it. Okay? That's it, guys. Peace out.